a few more examples of being able to find domain, range, intercepts, and then also evaluating a function at specific points by given the graph. We have this function right here. It looks similar to a function we graphed earlier in the course. So let's start by looking at the domain. And remember, domain is all the x values, right? So our domain D. Now notice that it's going to keep going forever to the right and to the left. And so if it just keeps going to the left and the right forever, once again, that means the domain is going to be all real numbers. So we're going to say x is an element of negative infinity to positive infinity. Now the range, though, is not going to be all real numbers. So our range, notice the y value, the lowest possible value is going to be 0. Okay, so we're not looking at the x value, we're looking at the y value. So we're going to say y is going to be an element of 0. And notice it actually touches the axis. So remember, when you use a hard bracket or a hard parenthesis, that means that it's going to include 0. Okay, so it includes 0. And then it's just going to keep going up, 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 up forever. And so that means that it's going to range from 0 to infinity, inclusive of 0. We never include infinity. Right? Next thing we're going to do is we're going to look for the x-intercepts. So where does it cross the x-axis? And it looks like that it touches, but that means that it crosses when x is equal to 1. And so two ways that we can write that. We can say that the x-intercept is at -1, or remember, at the x-intercept, y is equal to 0. Okay, so we have the ordered pair -1, 0. The y-intercept is right here, okay, at the point where it crosses the y-axis. So two ways that we can write the y-intercept. We can write that as 1 or as the ordered pair 0, 1, because recall that x is always equal to 0 when we write the y-intercept. And then finally, the last thing that we're going to do is we are going to just go through and evaluate the function at -4 and 3. So f at -4, we're going to go to -4, and then we're just going to trace it, and it looks like that it lines up at 3. Okay, so, and again, the point is that -4, 3 is on this function. And then when f is equal to 3, we just go to 3 and we trace it up, and it looks like it lines up at the point 4. Since 3, 4 is on the function, f at 3 is going to be equal to 4. All right, so that's how we go through and try to find domain, range, intercepts, and then also evaluate a specific function at points for one of these sorts of graphs of a function. Right. So here's another one. Right. And what you might want to do is just try this one on your own just to make sure you can do it. And there are actually two after this. So you might want to try both of these, okay, on your own. But I am going to go through these just to make sure that everybody understands the answers. But maybe pause the video, go through them yourself, and then try to go through the rest of them. So we'll start with the domain. And it just seems like in all of these, the domain just keeps going forever to the left, okay, because got an arrow, it's got an arrow. So we're going to say that x is an element of -infinity to positive infinity, all right? And that's going to be our domain. Now for our range, remember, we're looking for the lowest point to the highest point on the y values, all right? So notice that it keeps going down, 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 down forever. And so the range y is going to range from -infinity, and the highest it looks like it gets is right here at -2. And so that's what we're going to say, is that y is going to range from infinity to -2, inclusive of -2. Recall that when we have the bracket, it includes that value. Next thing we're going to do is we're going to find the intercepts if they exist. Now, x-intercepts are where it crosses the x-axis. And I want you to notice that it does not cross the x-axis anywhere. And so for the x-intercepts for this, there are none. And that's okay. Not every function is going to have x-intercepts. However, for the y-intercepts, there is one. And it's right here at this point at -2. So we could say that the y-intercept is going to be at -2, or as an ordered pair, 0, -2. Finally, we want to find f at -4 and f at 4. And this one's a little bit sneaky. So f at -4. All right, so we're going to go ahead. Let me erase this really quickly so we have a fresher view of the graph. All right, and so if we go to -4 and just trace it down here, it looks like that it's going to intersect right here at -5. So it seems to me that f at -4 is going to be -5 because the point -4, -5 seems to be on the graph of this function. And then when f is 4, it looks like that this is going to be the point 4 comma 2. And so f at 4 is going to be equal to 2. And we're done with this, okay? So these are our two values that we were supposed to find for these. Last problem. This one's a little bit different because it doesn't have any arrows on it. It has a finite segment to it. All right, so it's a curve. It's not a line segment, it's a curve segment. So for the domain for this, notice that the x values go from -5 to 0. Okay, so that's the x values, but it has a hole here at 5. And anytime it has a hole, that means it's not including that value in the domain. So we're going to say that x is going to range from -5 to 0, but there's a solid dot when x is equal to 0. So it's going to be a bracket at 0, but an open parenthesis at -5. Same thing for the range. For the range, we go from the lowest to the highest value that we see on the graph. And obviously the lowest y value is -3, and it includes that because it's a solid dot. But then we go up here to +4, and we have an open hole. So it's going to get a parenthesis, right? So again, lowest to highest, but make sure that if we have these open sorts of holes, that we don't include those values. X-intercept, that's where it's going to cross the x-axis, which is right here at -4. So two ways we can write that. We can say the x-intercept is -4, or we can say the point -4, 0. And once again, you might have heard me say this, but when the x-intercept is being considered, the y value is always 0. For the y-intercept, we're looking for the point where it crosses the y-axis. And fortunately for us, there is a point right here at -3. And so two ways we can write that. We could say -3, or if we were to write that as an ordered pair, 0, -3. And the reason we say that is because, well, -3 is going to be the y value. And remember that x is always equal to 0 when we're finding the y-intercept. Finally, we need f at -4, and we've already found that, believe it or not. So we just go to the graph where x is equal to -4. We see right here, and notice that the point is going to be -4, 0, which we actually found as an intercept in part C, and so f at 4 is going to be 0. All right, so that's a little bit about some of the basics of functions. And so if we go back, remember that we were able to find if a relation represents a function or not. We were able to find the domain, the range, the intercepts, as well as being able to find the function values. We were able to substitute values back into functions as well as algebraic expressions and simplify. And then finally, we were able to use the vertical line test to determine whether or not a relation is a function. So these are all really fundamental but important concepts regarding functions. So if there's any section that you want to try to focus on for this entire unit in section 1, this is a really good one to be able to build up your foundation for later sections. So that's all for this one, and we're going to take a look a little bit more about functions in the next section.